Hi guys, my name is Annie, and we will be covering the basics of fractions today. This lesson is called Foodie Fractions because I'll be talking about fractions through different foods. I'm Annie. I'm from India, but I've lived in 5 different countries in my life. I am a second year student studying psychology, and today I will be introducing you guys to fractions. So, this is the sort of summary, the agenda for today. What are fractions? What do they represent? What are they used for? We'll go over what the parts or the components of a fraction are. There's 3 different types of fractions that I'll be covering, and then at the end we'll have a short activity. So, what is a fraction? So, a fraction is a numerical representation of a whole object broken down into even parts. So, when I say whole object, a lot of the times that refers to one object, and you break it down into separate parts, and then out of those parts you calculate what parts you've taken away or what parts you keep. But you don't always have to have just one thing. So a fraction can be a representation of tiny different things. So for example, if I have 5 pens, 5 would be my total. So 5 pens are the whole in this case. And I'll try to explain that more as we go along. So for example, let's take this circle. Currently, it's just one circle, and the whole circle is the whole object. So I've currently drawn a line through the center of this circle, and this breaks the circle into 2 parts. So now the whole is 2 parts actually. So let's see this in the form of an actual example. So the same circle, I've broken it down into 2 parts. Let's say I take away one of those parts. I give it to a friend of mine. Now we only have one part left, one of the 2 parts. This is known as a half. We have only a half of what we originally had. So before you had the whole circle, now you've taken out half of the circle. You've taken out one part of the circle. In this example, let's say I have 2 pens, and I give this pen to a friend. That leaves you with 1 pen. 1 out of the 2 pens are left. Another more, I think, fun example is with food. This is a pie I ate a few years back, and that is my friend planning on cutting the pie into 8 even parts because I had 7 friends plus me. So we each wanted a equally sized piece. So we needed to break down that one whole pie into 8 equal parts. So then the whole is represented by 8 pieces. So we have 4 pieces, but they're not even. We have 6 pieces, again, they're not even. Now we have 8 even pieces, so that works out for everyone that wanted the pie. So currently, we have 8 out of 8 of the pieces remaining. 8 out of 8, as 8 is the separate as all the parts, 8 out of 8 is the whole. So when someone says 8 out of 8, when the top number and the bottom number are the same, they're referring to the whole thing, which is represented by the number 1. In this case, 8 out of 8 equals 1. The same refers to any fraction. So if I were to say 2 out of 2, that also equals the whole thing. You haven't taken out any of the parts from the thing. So currently no one has taken any pieces from the pie. So 8 out of the 8 pieces still remain. So the whole pie, the one pie, still remains. We've cut the pie into 8 pieces, and we've taken 3 of the pieces out. If I were to ask you, what of the what fraction of the pie have we eaten? You would say 3/8. The reason 3/8 is the answer is because, again, we've cut the pie into 8 parts, so the total number of parts, the whole is represented by the number 8. As we saw, 8 out of 8 equals 1. So 8 parts are the total. Out of the 8, we've taken 3 to eat. We only had three of the people there to eat the pie. The other 5 pieces were for the other friends who hadn't shown up yet. So 3 out of 8 here represents the number of pieces that have been taken out of the pie plate. So again, the question was, what fraction of the pie has been taken out of the pie plate? And that would be 3 out of 8. Reversely, I could also ask, what part of the pie is still in the pie plate? And you would reply with 5 out of 8, because 5 out of the 8 pieces, 5 out of the 8 is the fraction that refers to how many pieces are still within the pie plate. The pie plate is what I'm referring to as this thing here. So now I'm going to go through what the different components of a fraction are. So we've gone through some examples, but to be able to talk about fractions, we need to know what the different parts of a fraction are. So this is known as the fraction bar. This is what separates the top part and the bottom part of the fractions. This is known as the denominator. The denominator is what the total number of parts is, and on top, above the fraction bar, we have the numerator. The numerator refers to however many parts we are taking out of it or keeping in there, whatever we're referring to with the fraction. So in this case, maybe I have let's say I have a pizza. Let's pretend I draw this really nicely. And then I cut it into 2 parts and 4 parts, and so there's 6 pieces of pizza. Let's assume that they're equal. We have 1, 2, 3, 4, 5, 6. In this case, let's assume that I take out one of the pieces. Okay, I eat this piece here. It looks really delicious. I eat it. And then my friend comes back to the table and he asks, how much of the pizza is remaining as a fraction? And I would say 5 out of the 6 pieces are remaining. So 5 out of 6 is the fraction of pieces that remain from the original pizza pie. So let's go through some common important functions. So the first one we've already looked at before. This is referred to as 1/2, 1 out of 2, or 1/2 as it's known. The second one is 1 out of 3, or 1/3. And the last one is 1 out of 4, or 1/4. So these are a few common important fractions that people refer to quite frequently. So we've only used food examples, but fractions in real life sometimes come in handy when you have to bake, for example. There's a lot of sort of measuring you have to do. And if you've ever baked with your parent, then you might notice that the measuring tools used for baking have separate numbers on them. So if I want half a tablespoon, that will be different from a tablespoon as a measurement when baking. And so these kind of fractions come in handy sometimes then. So, proper fractions. These are the most common type of fractions that we've referred to so far. So these are just normal fractions where the denominator, or the bottom number, is bigger than the numerator, the top number. Improper fractions, however, are the opposite, where the numerator, the top number, is bigger than the denominator. And then we have mixed fractions. So these seem a bit complex, but really they're quite simple. So we have two pies here, right? We have pi 1 and pi 2. And so these are two pies. Let's say I have one pie here that is untouched, but the second pie I break into 8 parts. And then I decide I'm quite hungry, so I'm going to eat some of the pie. I decided to take out this large chunk of the pie. I've taken out 3 pieces from the second pie. So, if I were to ask, what fraction of the 2 pies remains? You would say 1 and 5/8 of the 2 pies remains, because we have one whole pie left, and out of the second whole, the second pie, we only have 5 pieces left. So let's reflect. What have we learned so far? The first question is, what are the different components of a fraction? I'll let you think about it for a few seconds, a few moments. So the different components of a fraction that we've covered, and if you need more time, feel free to pause, are the fraction bar, which separates the top number and the bottom number. And those two numbers are referred to as the numerator, i.e. the top number, and the denominator, the bottom number. The second question is, what are the 3 different types of fractions? So proper fractions, the common types of fractions that we've seen throughout this lesson, are when the bottom number or the denominator is bigger than the numerator. Then the second type of fraction is the improper fraction, which is a bit more rare, and you probably won't be covering it too much, but it's important to know about, is where the numerator or the top number is bigger than this bottom number, the denominator. And then the last type of fraction that we saw was mixed fractions, where you have a whole number and a fraction. So in the previous example, that was we had 2 pies, so the whole number was the 1, and 5/8 was the fraction from the second pie. So the last question is more of a reflection or like a thought example. And when do you use fractions? When else can you use fractions in real life? Have you noticed any time when you refer to fractions, or without actually calling them fractions, but when you have to utilize the skill of a fraction where you represent the whole in separate parts? Think about it. Foods are a great example, which is why I've used them throughout this presentation, and baking is another example. We get to do the fun activity now. So these are the safety rules before we start the activity. Please listen to and follow the instructions carefully. Do not eat or drink during the activity. Keep your hands and all materials away from your eyes, nose, mouth, ears, and other people. Please do not run. Make sure your shoelaces are tied. Do not throw materials to each other. Tie back long hair, and keep electronics away from liquids and heat sources. So this is the ball activity. So what you will need is a ball, or if you don't have a ball, like I don't have a ball, you can scrunch up a piece of scrap paper or old paper. You need an empty bin or something that you can throw your ball into. So when I did my activity, I threw my ball into this pouch, 1 sheet of paper, and a pen or a pencil. So this is the procedure. So on the sheet of paper that you have now, you can make a table like this. So we will be doing 10 tosses. 10 is the total number. And on the second column, you will be writing how many balls that you make into the bin, or in my case, the pouch, and how many times you miss the ball. And any chart of this sort would work. Once you've drawn the chart, place the empty bin or whatever you're throwing your ball into on the floor and pick up the ball and take 10 steps away from the bin. So I've already done this, I'm not going to do it again, but I will show you my results and you can either pity me or laugh at me because of my results. So standing from there, 10 steps behind the bin, try to toss the ball into the bin. Record your result in the chart you made and keep tossing the ball and recording results until you've tossed the ball 10 times. So for each column, count the number of check marks and record the total, and then represent each total as a total out of 10, so as a fraction. So I remember what I got on the ball activity, so I will write down my score. First try, I missed, unfortunately. Ooh. First chance, I missed the ball, unfortunately. But the second time around, I made it. Third time, I missed again when I did this activity. Fourth time, I also missed. Fifth time, I made it, thankfully. I made it a sixth time. And then I missed again. And I missed another one. And a third one for good measure. And thankfully, on my last one, I was able to make it. So I did save my game. I wasn't a complete failure in this game. And so I was able to make, out of the total balls in the bin, I made 4. And missed balls, I missed 6 of the balls. So out of 10, I've now represented the times I made the ball into the bin as a fraction and the times I missed the ball as a fraction. So if I were to ask you, how many times did I, Annie, make the ball into the bin as represented by a fraction, you would say, out of 10, I made 4 of the balls, or 4 out of 10 balls I made into the bin. If I were to ask the same about the missed balls, you would say, Annie made missed 6 out of the 10 balls. So yeah, I hope you guys all do better at this ball game than I did, and I hope you enjoyed. So thank you for engaging with me. If you have any questions or comments, we love to hear it. Email Start Science and visit our webpage, www.startscience.org. Yeah.